Okay, class, I wanted to give an example of how to construct a frequency distribution from a homework problem. So if they tell you here's a data set, these are some placement scores for like a test, let's say, and they tell you they would like you to construct a frequency distribution where they give you the first class, and in this case they say values between 472 and 492 inclusively. What that means is if I'm designing a frequency distribution, I would need a column for my classes and a column for my frequency for each class. And first thing I want to do is figure out how many data values I actually have, okay, so that I can keep track of my frequencies. So I look and I see, okay, this has a column of 6, and there's 1, 2, 3, 4, 5. 6 times 5 is 30. So I know up front that n, the number of items that we're talking about, is 30. Okay, so I have to make sure that in the end, my frequencies sum up to 30. Okay, then I notice that the smallest number that I have represented in this example is in this class, 472 to 492. So I would actually recommend sorting the actual data. And if you go ahead and do that, you would say, okay, my smallest data entry here is 470 what? Let's see, 473 it looks like, right? So if I take a look at my data itself, looking in the 470 region, I see that I have a 479 here, a 474 here, and let's see, any other 470? There's a 473. So I'm going to take this 473 as my smallest. So if I'm rewriting this, 473 is my smallest, followed by my next data value. After 473, the next one I come up with is 474. Let's see where we find that. There he is. And I can maybe rearrange them horizontally here so you can follow with me. 474. The next one that I find is 479. Let's see where we find that. That's right here. So 479. The next one I'm finding is 480. Do you see where that is? Yep, there's 480. So 480. Followed by the next data value of 485, I believe. Let's see if we find that. 485, do you see it? 485, where is that? Right here, right in front of me. Now so far, would all of these values be in that first class? Well, yeah, technically, 473 through 485, they would all fall into that first class. So let's keep finding any other values in that class. After 485, we would have, I believe, 492. Oh, there it is. So 492. And is there another 492 somewhere? Do you see it? 492, yep, right here. So those would be all the values just in that first class, 472 to 492. So as far as the frequency is concerned, how many items are in that class? It looks like 1, 2, 3, 4, 5, 6, 7 items. So that would be the frequency of that class. Now, to get the other remaining classes, what I would need to do is continue understanding what the class width was for my first class. So to determine the class width here, one thing you might think incorrectly is that the class width is 20. If you just subtract 492 minus 472, you get 20, right? But keep in mind, what if the class was the numbers 1 through 5? If you subtracted 5 minus 1, you'd get 4. But in reality, you had 1, 2, 3, 4, 5. So a fast way to understand the class width when you're given one of the classes is to subtract and then add 1. So you're actually including the boundaries. So 492 minus 472 is 20. Add 1 to it. There's actually 21 numbers represented here. 472, 473, 474. You can count all the way up to 492 and you get 21 numbers there. So if you know that the class width is 21, by subtracting the boundaries and adding 1, the class width is 21, then that means my next class would start at the next number, 493. And notice how if I added 20, I got to this number here. So that would be adding 20, I would be at 513. Notice also that if I subtract the lower bound limits, consecutive ones, 593 minus 472 gives me my class width of 21, and 513 minus 492 gives me my class width of 21 again. So there's 21 numbers included in each class. Okay, so now I'm saying for my next class after that, I would start off at the next number, 514, and I could do it a couple ways. Again, I could add 20 to this number, which is 534, or I could have added 21 or 21 to the endpoints, and you'd get those next numbers. Similarly, we'd start at the next number, 535, add 20 to this, and we get 555. Or if you added 21, the class width, to the boundaries, you'd end up with these numbers as well. Next up, you get the next number after 555, which is 556. Add 20 to that number, you get 576. Again, that's the class width of 21 if you subtract consecutive bounds. And then finally, for your last class here, at least it looks like it'll be our last class, we'll have to verify that. We would take the next number after 576, which is 577. If you add 20 to that number, you'd end up with 597. And again, subtracting consecutive bounds, you'd end up with 21, the class width again. Now, why do I stop there? Because the data actually doesn't go higher than 597. You can take a look at the data. If it had a number like 603, for example, we would need another class, wouldn't we? Okay, so you go up as far as you need to for the classes. So to continue this process, you would then continue after 492, and the next number I see is 496. Let's see if we can find that. There he is. 496. Notice we had a cutoff right here. This was class 1, right? That was the end of class 1. So let's look at 496. That's in our second class. After 496, I'm finding 500 right here. After 500, I'm finding 502. Do we see 502? There it is. After 502, I'm getting 508. Do you see it? There he is. After 508, I found 510. Did you find it? We're just sorting the data. And there's a lot of technology that'll do this for you, like Excel or TI calculators in the statistics mode. And after 510, I found 517, but I want to make a note at this point. Do you see 517, by the way? 517, yep, right there. Right here, I notice that's the end of class 2, right? At 513, that's the boundary. So it looks like 496 through 510 are in my second class. Let's take a look at what the frequency would be then for that second class. 493 through 513. It would be 1, 2, 3, 4, 5 items. So I need to put 5 items as the frequency of that second class, 493 through 513. Okay, so now we continue getting the values for our third class by continuing looking for data just slightly higher than 517. So after 517, I'm finding 525. Do you see that? 525. Yep, there it is. After 525, I found 527. Did you find 527 anywhere? 527. There he is. Yep. 527. After 527, I'm finding, let's see, 529. Do you see 529? There he is. After 529, what did you find? 532? Let's see, there it is, 532. And after 532, I'm finding something that's above this class. I'm finding 538. Do you see that? 538. So that's not going to fit in this class. That's actually going to be in the next class. 538 would be next. Okay, so what was in class number 3? For 514 through 534. 513 through 534. Can we see it? That's right. You would have a total of 5 entries there, wouldn't you? 513 through 534. We would have these 517, 525, 527, 529, 532. That's 5 entries, so that frequency for that class is 5. All right, so let's head over to finding our next class, 535 through 555. We already have 1 entry, 538. What do we find after 538? Did you find 2 copies of 545 anywhere? There's one of them, 545. Any other 545s you spot? That's right, right here, 545. So you have 3 entries so far in that class. After 545, I found 553. Did you find 553? Yep, there he is. 553. And again, we're getting pretty close to the end of this class. Let's see if there's anybody else in that class. After 553, I found 557. But notice that's not going to fit into this class. So that's actually the end of that class. Now we're going to have a new class starting with this entry 557. So let's see if we can count up how many entries we had in the class 535 through 555. How many entries did we have? Did you count 4? If you did, that would be correct because we had the 538, 545, 545 again, and 553. So 4 would be the frequency for 535 through 555. And if you continue this process, you'll see that I'm running out of space here, but you should end up after 557 getting 558, 561, 566, 567, bringing your total for the next class to 6 items. And when you count up the entries between 577 and 597, you'll end up getting 578, 596, 597. I think I missed one in the last one. I said there were 6 items. There was 557, 558, 561, 564, 566, and 567. But then at the end, to get the last category of 577 to 597, you'll have 578, 596, and 597. That's a total of 3 items. Now, how do you know that you have them all? Again, make sure you list them all out and check it all carefully. But remember the total was 30. Add up your frequencies. We often use the symbol sigma for sum. If you add up the sum of the frequencies, you have 12, plus 5 is 17, plus 4 is 21, plus 6 is 27, plus 3 is 30. So yes, we have accounted for everything. Every data value has been accounted for. It has its own representative class. And we have made a frequency distribution based on being told what the first class was. I hope this has been helpful for you. If you have any other questions, feel free to reach out to me by email. Otherwise, happy practicing, and remember, math is not a spectator sport. I'll see you next time.